The first research topic is oxygen separation from air. As you may know, the amount of the oxygen production is increasing because by using pure oxygen, melting furnace, syngas production, and those applications can be more cost effective and its energy consumption can be much reduced. Also, the use of the pure oxygen is suitable for carbon capture and storage. This figure shows the power consumption to produce pure oxygen from several gases having oxygen. As you may know, air has a 21% oxygen, meaning it requires 0.08 kilowatt-hour per cubic meter to separate pure oxygen from air. But at this moment, current technology requires 0.35 to 0.4 kilowatt-hour per cubic meter to separate pure oxygen, meaning efficiency is only 20%. But by using oxygen permeation membrane that we are doing research on, the energy consumption can be reduced down to 0.27 or something like that. This figure shows a schematic diagram of the oxygen permeation membrane. This membrane is dense ceramics dense and can conduct oxide ion and electrons. So basically, any gas molecule cannot penetrate this membrane. But oxide can conduct from high PO2 side to low PO2 side as an oxide ion. So by using this oxygen permeation membrane, pure oxygen can separate at one stage, and this is a continuous separation process. So initial investment cost can be much reduced. So, and it brings us the advantage of the compactness and high efficiency. But to use this material in reality, we need to further increase the oxygen flux and to reduce the operating temperature. For that purpose, we are trying to develop novel membranes and also develop high quality thin films. Also, enhancement in the surface exchange reactions is required. By preparing the high performance oxygen permeation membrane, in addition to these applications mentioned before, oxygen permeation membrane can be used for cathode materials in SOFC and other promising applications. Okay, so now let me explain how we measure the electrochemical property of the oxygen permeation membrane and the solid oxide fuel cells. Such the materials operate at a very high temperature, such as 700 to 1000 degrees Celsius. We need to use this kind of the setup made of refractory materials such as aluminum. And now he shows how this setup works. Usually this kind of a setup has two compartments to give two different gases, that is oxidant and fuel gases. The sample cell is mounted on the inner tube with the sealing material. This is glass. And in addition to that, current collector and thermocouples also placed inside the tubes. Then the setup is put in the furnace, and the electrochemical performance is measured by using various gases.